So for my topic, the journal I chose is all about an investigation into the flowability of the fine powders used in pharmaceutical industries. This topic is from the works of Vivek Garg, S.S. Malik, Pablo Garcia, and et al. In 2018. So there are three main outlines topic, which are the particle size distribution and specific surface area, the bulk and particle densities, and powder flow property testing. So uh, so the so the first part, we have the particle size distribution and specific surface area. So according to them, the laser light scattering was used to assess the particle size distribution and specific surface area in into in use in a flowability of fine powders. So for bulk and particle densities, the bulk density of a powder is calculated by dividing mass by its volume occupied. So the bulk density of a powder will change dramatically depending on the various process it goes through, such as packaging, compaction, consolidation, fluidation, and so on. So the random loose packing of a powder is presented by loose poured bulk mass, which is determined by allowing slightly aerated powder to settle in a container under the influence of gravity without the application of any other external loading. So since it will resist collapsing, powder with high structural strength, example for solid particle wall bonding, will have a low bulk density. So powder flow property test. So next is powder flow property testing. So we have the flow properties of calcium sulfate and the calcium phosphate were experimentally determined according to them in TAPAR, University's Laboratory for Particle and Bulk Solid Technologies using a powder flow tester. So from Brookfield Engineering Laboratories in Middleborough, USA. So GenX technique is applied to the powder flow tester. The sample is filled into an annular shear cell, and consolidation stress applied to the powder by annular lead. For the PFT, the axial torsional speed were 1.0 mm per seconds and 1 revolution per hour. Respectively, these were used to create shear sample as it was being compressed at room temperature from 22 degrees Celsius to 25 degrees Celsius. Samples were placed in the annular shells aluminum through. So we have the two topics. There is the flow properties of two common pharmaceutical excipients, which are the first powder is the calcium sulfate and the dicalcium phosphate, as well as the specification for feeder hopper design because of a lack of fundamental understanding of powder flow properties and their impact on hopper design parameters. Pharmaceutical companies face a slew of problems related to poor powder flowability.